Now we are going to see the characteristics of a NPN transistor in common emitter configuration. So in this configuration, any mode, the transistor having three characteristics: one input, output, and transfer characteristics. There are three characteristics in the transistor. This is a circuit for the transistor in CE mode. So first we see about the input characteristics. In the input characteristics, we are going to measure the input current IB by changing the current voltage of VBE at a constant VCE. Okay, this VBE is increased in suitable steps. At the same time, IB current should be noted for the constant value of VCE. Next, we draw the graph for the VBE and IB at constant VCE. This is the input characteristics curve. So VB is along the x-axis, IB is along the y-axis. This curve is not a linear, it looks like a curve. Okay, so from this curve is constant for the particular VCE. So input impedance can be defined as the change in base emitter voltage to change in base current at a constant VCE. This input impedance value should be very high. It should be very high. From this curve we can understand this curve look like a forward characteristics of an ordinary PN junction diode. The knee voltage for the silicon is 0.7, germanium is 0.3. Beyond this knee voltage, the base current is increases with the increase in base emitter voltage. Okay, and then from this graph we can understand that when increase in the collector emitter voltage, it decrease the base current. That means it shift the curve towards outside. Okay, because of increase in the collector emitter voltage, increase in the width of the depletion region in the diode. Next we see the output characteristics of the transistor. So in the output characteristics of the transistor, we are going to measure the current IC by changing the VCE at constant IB. The constant current is changed by the adjusting the VBE. Okay, by adjusting the VBE, IB current is kept a constant. VC is increased in suitable steps. Corresponding IC current is noted. Okay, so for at a constant IB current, we have to draw the output characteristics curve. VC is along the x-axis, IC is along the y-axis. Experiment for the different values of IB. Then in the output characteristics curve, we have in the four important region. One is a saturation, cutoff, active, and breakdown region. First we see the saturation region. In this region, when the VC is increased above the zero voltage, the collector current is increases to the saturation value. It is independent of the IB. Such a voltage is called knee voltage. So in this knee voltage only transistor should be operated. Okay. Next come to the cutoff region. In the cutoff region, the small collector current IC is existed even after the base current reduces to 0 because of the presence of minority charge carriers will be across the collector base junction and the surface leakage current. This current is collector base junction and the surface. This region is called the cutoff region because in this region mainly collector current should be cut off. That means 0. Okay. Next come to the active region. In this active region, emitter base junction is forward bias, collector base junction is reverse bias. So in this region, the transistor can be used for the voltage, current and power amplification purpose. Okay. At last region, breakdown. breakdown region means if the collector emitter voltage is increased beyond the value rated value for the manufacturing of the transistor, the collector current is increases. It will be leading to the breakdown region of the transistor. So this avalanche breakdown, it will be damage the transistor. Next we define the output impedance. The output impedance is nothing but a ratio of change in the collector emitter voltage to change in collector current at a constant base current. So output impedance R0 is equal to del VCE divided by del IC at constant IB. This output impedance for the transistor is very low. Next transfer. It gives a variation of collector current with changes in the base current at a constant collector emitter voltage. Okay, from this the small IC current will be flowing even though IB current is 0. This is called common emitter leakaging current, which is due to the flowing of minority charge carriers. Flowing of minority charge carriers. Next we draw the graph between IC and IB at a constant VCE. It can be defined the ratio of change in collector current to change in base current at a constant collector emitter voltage. It is called as the forward current gain. So beta is equal to del IC by del IB at constant VCE. This value lies between 50 to 200. And then it depends upon the transistor and it will be provided by the manufacturing. In the some transistors are having beta should be above 1000. That's all. Thank you.